Christoph.
Okay, so as I said, my name is Christoph Schütz from the University of Linz, and I'm presenting a paper, a journal paper that we've published earlier in the Semantic Web Journal earlier this year. It's joint work with colleagues from the FBK in Trento. Loris is also here, and yeah, we will also later be in the poster session. So I'm giving you only the main intuition, and then I'm happy to later discuss it in the poster session as well. Okay, so our paper, so we presented an approach that we call knowledge graph OLAP. The idea is that we have contextualized knowledge graphs. So basically, we have knowledge graphs that, or we have a larger knowledge graph that is composed of different contexts. And then we have special query operations that we can use to work with these knowledge graphs. Yeah, to understand the intuition, on the left-hand side, you see OLAP with numeric measures where each cell of the cube, each context, so to say, consists of a numeric measure. Whereas on the right-hand side, you see our knowledge graph OLAP approach, where each cell in this multidimensional space is basically a context for a knowledge graph, or basically knowledge triples. We can then distinguish two different kinds of operations. So on the one hand, we have now the merge operation, which in traditional traditional OLAP, traditional online analytical processing, basically, yeah, corresponds to a group by, where we say, okay, we take all the numeric values from the different cells and put them together. And the same basically happens in knowledge graph OLAP. So we can say, okay, now we want to group the different contexts by region, by package, whatever we have, and basically just merge the smaller knowledge graphs in the different contexts to obtain a larger knowledge graph. And then the second step, after we've performed this merge, we can perform an abstraction. So in traditional OLAP with numeric measures, what we would have then is apply some numeric aggregation function like the sum operator to obtain from a set of numeric values a single result value. So in this case, we just sum up the numeric values that we've previously obtained from the individual cells. In knowledge graph OLAP, we could have different kinds of abstraction operations. For instance, we could replace individual entities in our knowledge graph by more abstract entities to take the place. In our paper, we illustrated our approach using the case of air traffic management, where we can find, which is a natural fit for contextualized knowledge graphs. So we have different types of messages that represent the state of air traffic, of the air traffic system, and then we have different contexts, different geographic contexts, different flight information regions, as they are called. And then also we have temporary changes. So for instance, navigation aids can be temporarily closed in a specific temporal context, or some information might be relevant for a different geographic scope. And so what could we use this for then? Well, we could build, for instance, such a knowledge graph OLAP cube to support a pilot briefing application. But I'm happy to discuss the details later. Maybe just let me briefly finish with giving you an overview of our current ongoing research in this direction. So basically now, so we ask ourselves, how does it scale? Well, with the proof of concept implementation that we used, or that we first came up with, where we use an RDF database and Sparkle-based implementations of the query operations, it's probably not realistic to consider a monolithic knowledge graph OLAP cube for air traffic management in Europe in its entirety, but it's enough for building one knowledge graph OLAP cube for individual pilot briefings. So that's currently the scope. But of course, we would like to also allow for big knowledge graphs. So here we are currently following different leads. But I'm also happy, I think, to discuss this later in the poster session. Thank you.